Alrighty, we have a cool looking limit integral here. Usually, when it comes to limit integrals like this, one of the biggest advices I was given uh, is to I guess the best way to explain it is like it's technically a piecewise function, right? If you're given things like, let's say like -1, 1, and then you have like absolute value, right? Then this is obviously a piecewise function because negatives, you have to separate the negatives and you have to separate the positives, right? Or technically in this case, this is just like this, pretty much. Um, so that's technically what it doesn't look like this limit integral does not look like a piecewise function, but it technically is. And the reason is because of the domain. And I can explain that to you. The domain, whenever you have x between 0 and 1. Well, let me first explain like between 1 and infinity. We all know that like we mostly assume that when x is infinity, I mean not x, uh, when when we have x to the power of infinity, then it's obvious that this is going to equal infinity, right? But you have to be very careful because when it's between 0 and 1, this is not true, right? So uh, if I can just simply show you, right? If we have 2, this becomes 1/4, right? 1/4 is definitely smaller than a half, right? If we cube it, then this becomes 1/8. 1/8 is definitely smaller than 1/4 and smaller than 1/2. So as as we get um, as this n gets bigger, right? We are actually approaching to 0. So this right here is actually equal to 0. So that's why I say that this limit integral is technically a piecewise function because depending on the domain, x can behave differently when n approaches to infinity, right? If x is between 0 and 1, it's going to equal to 0. If it's 1 to infinity, between 1 and infinity, then of course it's going to go into an infinity. So that's how we deal with most limit problems like this. This is the I would consider this like a basic limit integral because there are limit integrals where you do have to do like some special cases that require some experience. This is a good basic limit integral to start off with. So here we know that from 0 to 1, then 1 to infinity, we have to sort of like, we have to split it up. Here, in this case, we have 0 to 2020. So, I mean, we could just change this to 2020. It doesn't necessarily have to be infinity. So we could definitely split this integral, right, from limit n approaches to infinity of 0 to 1, inverse tangent xn plus 1, and then plus from 1 to 2020, inverse tangent xn plus 1. Cool. All right. Now, if you plug in n to infinity, if you plug in n to infinity here, well, between 0 and 1, it's equal to 0. So this is inverse tangent of 0 plus 1, which is equal to inverse tangent of 1, which is equal to pi over 4. So it's pi over 4, right? And then here, 1 to 2020, right? Uh, between 1 and 2020 in the domain, x to the power of n, if you plug in infinity here, then it's going to become infinity. So here, this whole thing is going to be infinity. Inverse tangent of infinity is pi over 2. And now we get pi over 4 plus pi over 2, like 2020 minus 1, that's like 2019. And so this is technically our answer here. You can definitely simplify if you want to, but you can. I'm just gonna leave it like this because I'm lazy. So this would be my answer: pi over 4 plus pi over 2 times 2019.